All right, so to recap what we were doing with absolute or conditional convergence, if the absolute value of the series converges, then the series itself converges too, and that's considered absolutely convergent. If the absolute value diverges, but the series itself converges, then that's considered conditionally convergent. And if they both diverge, then the whole thing just diverges. So number one, which of the following are conditionally convergent? This is going to be a little bit of work here because you have to check all three of them. So let's look at letter I here. So if we do the absolute value of this, that is going to just be 1 over n. And so that's the harmonic series or a p series where p is 1, and so that diverges. So far, so good. The absolute value is going to diverge. Now we need to check the series itself. It is alternating, which actually I think they all were. These are all alternating. So your alternating series test, the limit as n goes to infinity of the series, so 1 over n has to equal 0, which this does. And then the terms have to be decreasing. So the n plus 1's term has to be smaller than the nth term, which is true. And so this converges. So since the absolute value diverges, but the series itself converges, that is conditionally convergent, so we want that one. All right, so next one. If we do the absolute value of that, it's just going to be 1 over n cubed. So that's a p series where p equals 3, and that's bigger than 1, so that converges. So that means this one is absolutely convergent, not conditionally convergent. So we do not want that one. And then last one, if we do the absolute value, that's going to give us 1 over square root of n. That's n to the 1/2. So p is a half. And so that diverges. So the absolute value diverges. Now we're going to do the series itself, which again, it's alternating. So we're going to do our alternating series test. This limit has to go to 0, which it does. And then also the n plus 1th term has to be smaller than the nth term, which this denominator would be bigger than this denominator. So it is the smaller fraction. So that converges. So that one is also conditionally convergent. And so we would want 1 and 3, which is C. So that one was a good bit of work, but not that hard. Like each one of them wasn't too terrible there. And then this one is much the same. We're asking what's true about this series, and it's talking about absolute and conditional convergence here. So if we do the absolute value of this, that will give us 1 over the cube root of n. And so n is 1/3, and so that diverges. So then we're going to check the series. Oh, so it can't be b. If the absolute value diverges, then it can't be absolutely convergent. So it can't be b. So then we're going to check the series itself. Once again, it's an alternating series due to this -1 to the n. So limit as n goes to infinity for this, that is going to be 0. And the n plus 1th term is smaller than the nth term. So that converges, and it is conditionally convergent. So that one is A. And honestly, that problem was almost the exact same thing as this third one here. The only difference is instead of a square root, it was a cube root. So if you honestly, like if you just did this problem and then you looked at this one, you could almost just pick that without even doing the work there. All right, number 3, which of the following is conditionally convergent? For the sake of time here today, because I want to have enough time to go over a lot of your study guide, I'm going to just do the one that's the correct answer. If you want to look through why the others are not the correct answer, just swing by office hours and I'll do that for you. The right answer is C. So let's look at that one. So if we do the absolute value of this, that is going to be just this 17 plus square root of n over n. And so we're going to do a comparison test. So I'm going to compare this to just a square root of n over n, which would be 1 over square root of n. And so for that, P would be a half. It's a P series, n to the 1/2. And so that diverges. Now, because it's multiple choice, because your two choices when you're doing a comparison, you can either do a direct comparison and you have to show which one is the smaller one and which one is the bigger one, or a limit comparison, and you would have to do the limit as n goes to infinity of this one over this one and show that it comes out to a positive finite number. But if it's multiple choice, you don't have to finish off that proof because you just have to be able to pick the right answer. So this one diverges, so this one's going to diverge too. So the absolute value of this diverged. And then we're going to check the series itself. Now, again, it's alternating because this -1 to the n plus 1. So we're going to do alternating series test. And so this limit as n goes to infinity. In the numerator, we have an n to the 1/2. In the denominator, this is n to the first. So 1/2 is smaller than 1. That is going to go to 0. And then the n plus 1th term has to be smaller than the nth term. So I just plugged in n plus 1. That's going to be smaller than the nth term. And that will be true. This denominator is bigger than this denominator, so it's going to be the smaller fraction. I realize we added a 1 here as well, but we're square rooting that. It's not going to be a very large change. Again, this has the bigger denominator, so it's going to be the smaller fraction. And so that converges. So absolute value of it diverges. The series itself converges. And so that's the one that is conditionally convergent. That is a really hard question. Not like hard, but a lot of work just for one question, because you would have to test, each one of those. So that's a question like on the AP exam, I would honestly skip it and just come back if I had time, because that's a very time-consuming question. Right, and then number 4, for what values of P is this series conditionally convergent? All right, so we need for the absolute value of this to diverge and for the series itself to converge. So if we look at the absolute value of this, that would just be this. We need for this to diverge. So I'm going to do a comparison. So I'm going to compare that to n over n to the p power. Basically just getting rid of that plus 2 over there. And so if we reduce this, this is really n to the first. So this is going to be 1 over n to the power p minus 1. You could think of it as subtracting your exponents. It's 1 minus p, but if we put it in the denominator, it would be negated, so p minus 1. That's really weird with your exponent rules there. But anyway, if we want this to diverge, it would be a p series. We need this p minus 1 to be less than or equal to 1. That will cause this to diverge. Again, if we want to be conditionally convergent, this absolute value of the series has to diverge. So this would have to be smaller than or equal to 1. And so p has to be less than or equal to 2. And so you can honestly pick the answer just based on that. This is the only one that has a less than or equal to 2. But for the sake of being thorough, let me finish this up. We would need this series itself to converge. It is an alternating series. So we need the limit as n goes to infinity of this to equal 0. And the only way that is going to happen is if p is bigger than 1. Because if p is smaller than 1, like say p was a half, you would have n to the first over n to the 1/2, then this limit wouldn't go to 0, it would go to infinity. But if p is bigger than 1, like say p was 1.5, then the denominator would be bigger, it would go to 0. So anyway, it's got to be bigger than 1, less than or equal to 2. So that was a hard question. All right, and then this last one, it says, consider the geometric series. If they tell you something is geometric or a p series, that's like hallelujah, because those are the two easiest ones to deal with. So I can already tell I'm going to like this question better than the other ones. All right, series is geometric. The first term of the series is 48. And then the third term of the series is 12. So here's what's going on. Our first term is 48. I don't know what the second term is, but then I know the third one is 12, and then so on and so forth. So which of the following is true? So A says that the sum is 64. B says that the sum is 96. C says it converges, but we can't figure out what the sum is. And D says it diverges. So what I would do is try to figure out what this middle term is. If this is geometric, we have to be dividing by the same amount each time. So if this is 12, I know that this middle term is going to have to be 24. We're dividing by 2 each time. So 48 divided by 2 would be 24, divided by 2 would be 12, and so on and so forth. So the R value is a half. We're doing a half each time. And again, if you have that series recap open in another tab, just look at that. Look at the part where it talks about geometric series. If R is smaller than 1, it's going to converge. So we can get rid of D. And then the sum equals A over 1 minus R. A is the first term, and R is that ratio that you're multiplying by each time, which in this case is a half. So for this series, our first term is 48, and then over 1 minus a half. So that is 48 divided by a half. Dividing by a half means you're multiplying by 2, and so that will come out to 96. So that one is B.